Okay, over to our final speaker, which is Johnny Kung, who's the part of the Personal Genetics Education Project at Harvard University. You can see they've all got the technology sorted. All right. Working.
Okay, so thank you very much to the organizers for inviting PGX here. I know I'm the last one standing between you and the boat trip, and I think my talk will be a little different from a lot of the talks you've heard in the past couple of days, so please bear with me. So the Personal Genetics Education Project, based at Harvard Medical School, we consist of a pretty small but diverse team of people from many different disciplinary backgrounds. Some, including myself, have a basic bench research molecular biology background, and there are also people with social science background, people with education and community activism background. It was founded about 12 years ago by a director, Ting, who's a PI in the genetics lab in the department, co-founded with Dana, who is someone with a history of science background. Over the years, our main support has come from the department. Our chair, Cliff Taven, believes that because of all the technology that's coming out of our department, we have a moral duty to make sure that the community at large understands and is aware of what's going on. And in the past few years, we're also funded by a Science Education Partnership Award by the NIH. So our group's mission basically is to raise awareness and spark conversations about the benefits as well as the ethical, legal, social implications of personal genetics. And we try to include all voices in these conversations, regardless of their socioeconomic and educational background, their cultural, religious affiliation, or ethnic and personal identity. And when we go into the conversations, we do not promote for or against any particular genetic technologies, but instead we want to bring this information to as wide an audience as possible. So very briefly, what do we do? The bread and butter of what we do is to create these educational materials that we put online and make them freely available for anyone, any teachers and others in the community to use. Over the years, we now have about a dozen different lessons, including lessons on genetic reproduction technologies, on consumer genetics, personalized medicine, history of eugenics, our newest lesson on genome editing and CRISPR. And as part of the NIH grant, we are now making materials on race, ethnicity, and ancestry, sex and gender, and genetic intelligence. All fun stuff. So we bring this to students whenever we get a chance. We bring them to schools in inner city Boston and other cities that we visit on conferences, such as San Francisco, LA. We also, through some of our partners, bring them to schools in Maine, in South Dakota, in the middle of the country, and other places like that. But to really scale up what we do, we have to go through teachers. So by teaching the teachers how to use these materials and talk about these issues, we hope to bring them to more students. And so we've been organizing professional development workshops with teachers in Boston, in teachers' conferences around the country, and again, through our partners, go to other places around the country, around the US to bring these workshops to different teachers. And in the past couple of years, we've been also trying to bring this directly to the community as much as possible, particularly because of the important role that institutions of faith play in American society. We also bring it to a lot of churches and faith institutions. For example, this here was last year at Director Ting talking at a evangelical Christian college about genome editing and CRISPR. Here we're talking to the local Muslim community in Boston. And here we're talking to a coalition of African-American pastors and religious leaders in Baltimore. And something else that we do is we organize and speak at conferences for academic, industry, and community leaders. We work a little bit with Hollywood here talking to a salon of writers and producers in LA. And we also run a series of congressional briefings in Washington, D.C. to raise awareness of all these issues in our policymakers' field. So what do we talk about? Some of what we talk about is, again, related to the benefits and complications of genetic testing. And our previous two speakers have talked a little bit about some of the issues with this increasing common application of genetic technologies. So I'll just very briefly run through some of these. Genetic testing are now used in, at least being used in a lot of different applications, from newborn screening, as was mentioned, carrier testing, predicting risks for future possible diseases, prenatal screening, pharmacogenetics, and also include ancestry testing here, because even though that might not sound like health related, for a lot of people in the public, ancestry testing is kind of the avenue through which they enter genetic testing. So I'll just quickly go through a couple of applications, main applications. Pharmacogenetics is the idea, basically, because there are genetic variants that control affect the genes that control how our body metabolizes drugs. The idea is that if we can identify these variants in patients, we can give more correct drugs and more correct dosages of drugs. So this example is of codeine, where in the population, there are certain people who are poor metabolizers of codeine, so that with standard dosage of codeine, the drug's going to be metabolized less quickly into morphine and work less well in these patients. And then there are also rapid metabolizers who basically metabolize codeine into morphine too quickly, and so a standard dosage could potentially be an overdosage for these people. And then another type of pharmacogenetics is also sometimes called companion diagnostics, which basically used to try to basically stratify patients into different groups based on the genetic variants to see if which particular targeted therapy is suitable for them. This is used a lot, increasingly with various cancer drugs, which are designed to work with particular genetic variants. And so companion diagnostics is being approved along with these treatments. But for these to work, really, part of the problem is these drugs are expensive, and to use these tests with the drugs is going to be also expensive as well. And so, if with more of these patients do not receive this test, they're not going to benefit from the potentials of personalized medicine. And also, the evidence base of some of these pharmacogenetic tests is still questionable. One of the most talked about pharmacogenetic tests is for warfarin, but the evidence has been going back and forth over these years. And as you see in this outline here, I think the most recent consensus right now is that some of these tests might not really work particularly well and show much benefit. But the type of genetic test that is really pushing the conversation is this group of tests called consumer genetic testing, which is now being marketed and sold for a variety of applications, including carrier testing, risk prediction, ancestry testing, as I mentioned. There are companies that sell tests that are supposed to predict your kid's sports ability, and soon there are people talking about tests that might test for IQ. I'm sure a lot of people have heard of this particular company, 23andMe, where they're part of a group of companies called direct-to-consumer companies, which basically sell these tests directly to consumers without the intervention of physicians. But in recent years, there are also a class of tests which are physician-ordered. The patient can either ask the personal physician to order these tests, or the company can match you to a company-affiliated physician to order these tests. And with the decreasing cost of genetic testing and sequencing, there are now companies that would do whole genome sequencing, or at least exome sequencing, which is basically sequencing the parts of the genome that code for proteins. And this particular company has this model of basically an app store where, while you can there are companies that sequence the entire genome for around $2,000 or even $1,000. This particular company, Helix, they charge a less price for sequencing the genome, but then the customer can basically order individual applications. The most popular is this one on ancestry. There are also ones on health-related stuff, and also frivolous stuff like using your genetic pattern to create like a socks or clothes that are based on your DNA sequence. And as the previous speakers talked about, a lot of geneticists are now talking about something called polygenic scores, which is actually not completely brand new. It has been used in non-human genetics for a number of years, but with increasing genome-wide association studies, finding more and more genetic variants that are associated with particular diseases or traits. Again, a lot of hype about how polygenic scores could be used for predicting disease risk soon. And there are also a lot of interest actually in using polygenic scores for non-disease related traits, including, as I mentioned earlier, IQ. Again, there are a lot of issues with these consumer genetic tests that some of you have heard about some of them for sure. False positives is something that is still an issue with a lot of these tests. And this Alan here talks about how you can spend all money on finding nothing because a lot of times these tests still don't work particularly well in actually telling you useful information. Because sometimes even, especially with moving away from kind of the older type of genetic test with 23andMe, which is basically the company tests for specific variants in your DNA. We're moving more towards genome sequencing, where basically either sequence specific genes in a targeted manner or sequence the whole genome and find all kinds of variants that are in your genome. A lot of these variants are called variants of unknown significance. Basically, they find a variant, but they have no idea how that actually biologically affects the trait. And so what's the use of finding some of these variants, how it's going to affect people's understanding of risk and underestimation of risk, particularly in cases where if you don't find a risk variant for a particular disease, does that mean you're not going to develop that disease? Or if you find certain variants, what are you going to do with that result? Are you going to go straight to treatment, just finding particular genetic variants that increase your risk for breast cancer? How to kind of decide how to proceed towards treatment. So these are all questions that are still very much need to be discussed and answered as these tests get more and more into the market. The technology that really is entering the market at particularly high speed, I think probably one of the medical technologies that have entered the market most rapidly in recent years is non-invasive prenatal testing. It was first invented around 2011, 2012, which basically is based on the principle that the fetus and the pregnant person shares the bloodstream. And the fetus, technically the placenta, sheds pieces of DNA into the pregnant person's genome, and so the bloodstream. And so basically, by drawing blood from the arm, it's possible to identify pieces of DNA that come from the fetus. And from that, we can do genetic tests on the fetus. Its original main application is for identifying chromosomal aneuploidies, basically having an atypical number of chromosomes, including atypical number of the autosomes, so for example, trisomy 21 Down syndrome, and also atypical numbers of sex chromosomes, but actually also for the regular number of chromosomes, so you can actually identify the chromosomal sex of the fetus with this test, but then also identifying atypical number of sex chromosome resulting in conditions such as Turner and Klinefelter syndrome. There are also now applications of these tests to identify microdeletions, which are basically diseases caused by deletions of several dozens and several hundreds base pairs in DNA, and leads to some of these hereditary conditions. And in the past year or so, they're now selling tests for single gene disorders, including cystic fibrosis, and a lot more is on its way. It's also important to point out that the similar technology is also being applied for something called liquid biopsy for cancer, which is basically using this technology to draw blood from a patient and identifying circulating tumor cells and DNA, often from tumor that's precancerous or pre-symptomatic. So now that it's possible to use this technology to identify the genetic tests on fetuses, what do we do with this information? And that is something that, again, urgently needs to be discussed. This report came out of Iceland a few months ago, showing that this is without using NIPT, without using the non-invasive prenatal test. This is existing non-genetic ways of identifying fetuses that might have Down syndrome, and that has reportedly resulted in a drastic drop in the birth of babies with Down syndrome. So a lot of people from disability communities are concerned about what this easier to use test is going to do to their community. And similar concerns from intersex communities, people with atypical numbers of sex chromosome or other genetic variants, which lead to them falling in between along the spectrum between typical males and typical females. These tests are going to be able to identify these individuals before birth. So what does it mean for these individuals, these communities? And finally, as I mentioned, because some of these tests can be used, it is being developed to identify pre-symptomatic cancer in patients. So one consequence of that is that when expectant pregnant moms are using this test to try to do a genetic test on the fetus, sometimes they inadvertently identify potential cancers or tumors in themselves. So, which basically pushes the incidental discovery of cancer into a whole new level. So why do we care? Why does BGI do what we do and talk to communities about some of these issues, about the benefits and implications of genetics, and to get as wide a community involved in these conversations as possible? We do that because we know that there is a promise or a potential for some of these new technologies to actually save lives and address some of the potential, some of the existing health disparities in the US and in other countries. One of the big kind of precision medicine projects that are being launched right now is called the Precision Medicine Initiative, also called the All of Us Project, which actually specifically wants to increase, overrepresent ethnic minorities and other traditionally underrepresented communities in these genetic studies to identify genetic variants which might not otherwise be found in other populations. Because genetics and biological research traditionally has not been very effective, very inclusive in this way. Most of the large-scale biological studies and genetic studies are overrepresented with people from European ancestry. Even a lot of the testing companies that turn free and media databases are overrepresented with people from European ancestry. In recent years, there's been a slight increase in the number of people from industrialized East Asian countries, but for a lot of other populations, including ethnic minorities in Western industrialized countries, there's still a lack of information that's relevant to them. So let's just try to recruit more people, right? That's exactly what all of us are trying to do. They're trying to over-recruit from ethnic minorities and other marginalized communities to try to address this kind of historical disparity. But they're running into issues because biological research and And medical research traditionally has not done a very good job in working and engaging with a lot of marginalized communities. And there's a strong and deep historical distrust among these communities towards researchers and a lot of people from biomedicine. This example is the Tuskegee syphilis experiment, which happened from the, I think, the 1930s into the 1960s or 70s in Alabama in southern United States, where basically a group of poor black men were left with syphilis untreated for years, spreading the disease to the family and other children, because the scientists wanted to study the natural progression of syphilis. To this day, a lot of people from African American communities are still very suspicious of their local hospitals. They would even say something like, black people go to Boston University Hospital and get their organ harvested. In my home country of Canada, the shameful history of residential schools and so-called Indian hospitals also was historically used to basically use medical treatment as an excuse to bring First Nations and Inuit children to Southern Canada and basically try to assimilate them into mainstream culture. And that, again, has led to a continued kind of strong distrust of the healthcare system. And there are echoes of that in some experiment on Greenlandic children in Denmark and other indigenous populations around the world. And in a lot of communities that we go to when we talk about genetics, the first thing that comes to mind is not health, because to them, genetics and health is no relevance to them, because their strongest interaction with genetics is with the criminal justice system. In countries like the US and UK and Canada, Black and Indigenous folks are overrepresented in the DNA databases, partly because they're overrepresented in the criminal justice system. They are disproportionately arrested, convicted, and incarcerated, so that their DNA is overrepresented in these databases. So when we talk about recruiting them more for genetic studies, the first question would be, what else is my DNA going to be used for? Is it going to be used to basically continue this disproportionate monitoring, surveillance, and incarceration of my community? And this law was recently passed, I think in May in Germany, which increased the use of forensic DNA for crime and law enforcement. And this idea of DNA phenotyping is basically an expansion of the whole idea of using your DNA to kind of predict your phenotype, your hair color, eye color, skin color. The evidence basis for this particular technology is very shaky, but nonetheless it's being applied in the US, and this law in Germany now allows that to be used. There are existing laws and regulations that protect research data. For example, with the All of Us project in the US, they also passed something called the 21st Century Cures Act, which prohibits research DNA from being used for non-research purposes. But laws can change, and applications, unexpected applications can be used. For example, a few months ago in California, police basically used a public DNA database where amateur genealogists upload their DNA data from ancestry tests to basically try to find the relatives. The police were able to use that particular website, which was not designed as a criminal justice tool, to catch this potential suspect. And now law enforcement around the world, including Sweden, are clamoring to potentially use this application for this database. Of course, issues of genetic and health disparity is not restricted to ethnic minorities. As I mentioned earlier, some of these new technologies is expensive. A lot of the populations that were being used in these studies to create some of these research, they're unlikely to be able to afford some of these new medicines and technologies, especially in a country without universal health care like the US. for some people, using $100, $150 to buy a DTC genetic test is the only healthcare that they're going to have. So how are we even going to approach this issue and address issues of understanding the implications of what these genetic tests mean? And in the past couple of years, a lot of journalists and scholars have kind of waded into these far-right and neo-Nazi websites and shocked to find that a lot of these people are flocking to genetics because they're hoping to use this kind of ancestry tests as a way to prove racial purity and whatnot. So basically what I'm trying to say is we're going to talk to many different communities about genetics. Conversations like this cannot be separated from their social context. So I'm just going to end by going back to this story here. In 2016, we went to meet this group of mostly, again, African-American pastors and ministers from Baltimore and the American South. They are basically a coalition who are interested in how precision medicine could potentially be used for the community to address some historical health disparities. This meeting was originally supposed to happen in June or July, but it was postponed because a week before that particular meeting, it was announced that the verdict for one of the police officers who killed Freddie Gray, who was a black man who was unarmed black man, was killed in police custody. It was the date that the verdict was going to be announced, and the ministers were worried for safety and was being recalled to their churches to stand by and basically for any potential issues. But so the event happened in September. Originally, 100 pastors signed up for this event, and we were there. About half a dozen showed up. Some of the ministers who were there told us pretty straightforward that being someone coming from an institution like Harvard, that's not something that attracts them to this meeting. Because Harvard, to them, is the same as Johns Hopkins, the local biomedical hospital. It reminds them of kind of the issues that they've had with this institution, the story of Henrietta Lacks, the black woman whose cancer cells were used to create the HeLa cell lines, which are widely used around the world in biomedical research, but it was used without Henrietta's consent or her descendants' knowledge or compensation or anything like that. So, but nevertheless, we persevered. We had frank conversations in this small group. On the second day, we were invited to the church of one of the pastors to continue conversations. And since then, we've had the opportunity to invite them over to our institution to continue the conversations, and we've had more meetings since then. I think this story just kind of shows how far we still need to go in addressing some of these issues and involving diverse communities in these conversations, and how much more work still needs to be done. And a lot of this work was spearheaded by Jakia Cannon, who was a sickle cell disease patient, tireless advocate for some of these issues. There was a meeting where he actually helped us invite the granddaughter of Henrietta Lacks, Joey Lacks-Y, to one of the meetings to talk to industry leaders and CEOs of genetic testing companies to basically talk about some of these issues. Unfortunately, Shakir passed away last December, but we'll continue this work. Thank you.